In the beginning, Earth was a barren world of rock, water, and silence. There were no forests, no grasslands, no shade, and no oxygen-rich air to breathe. The land was lifeless, scorched by harsh sunlight and shaped only by wind and water. And yet, deep within the oceans, something extraordinary was already unfolding. Tiny, almost invisible organisms were beginning to harness the energy of the sun in a way that would transform the entire planet forever. These early life forms were not plants in the way we understand them today. They were simple, single-celled organisms, often grouped together in thin layers or clustered structures. Among the most important of these were cyanobacteria, microscopic organisms capable of photosynthesis. Using sunlight, water, and carbon dioxide, they produced energy and released oxygen as a byproduct. At first, this oxygen dissolved into the oceans, reacting with dissolved iron and other elements. But over millions of years, something remarkable began to happen. The oceans became saturated, and oxygen started to accumulate in the atmosphere. This transformation, often referred to as the Great Oxygenation Event, changed the course of Earth's history. Before this, the atmosphere contained almost no free oxygen. Afterward, oxygen levels began to rise, slowly but steadily. For many existing organisms, this was catastrophic, as oxygen was toxic to them. But for others, it opened the door to entirely new forms of life. The stage was being set for complexity, for energy-rich metabolisms, and eventually for life on land. For billions of years, life remained confined to the oceans. The land above was still a hostile environment. Without an ozone layer, harmful ultraviolet radiation bombarded the surface. There was no soil, no stable ecosystem, and no protection from extreme temperature changes. But as oxygen accumulated in the atmosphere, it began forming ozone, a protective layer that shielded the surface from the sun's most damaging rays. Slowly, conditions on land became less hostile. Around 470 million years ago, during the Ordovician period, the first evidence suggests that simple plant-like organisms began to make their way onto land. These early pioneers were nothing like modern trees or flowers. They were small, low-growing organisms, likely resembling mosses or liverworts. They had no roots, no leaves, and no vascular systems to transport water. Instead, they relied on moist environments, clinging to damp surfaces where water was readily available. Despite their simplicity, these early land plants marked a turning point. They began to interact with the bare rock, breaking it down through chemical processes and contributing to the formation of the first soils. This, in turn, allowed more organisms to establish themselves. The presence of these plants also began to alter the atmosphere further, drawing down carbon dioxide and continuing to release oxygen. As millions of years passed, plants began to evolve new adaptations that allowed them to survive and spread across the land. One of the most significant developments was the evolution of vascular tissue, specialized structures that could transport water and nutrients throughout the plant. This innovation allowed plants to grow taller and inhabit drier environments, no longer limited to constantly wet surfaces. By the time of the Silurian and early Devonian period, around 430 to 400 million years ago, the first vascular plants had appeared. These plants, such as Cooksonia, were still relatively small, often only a few centimeters tall, but they represented a major evolutionary leap. They had simple branching structures and spore-producing organs, allowing them to reproduce and spread more effectively. The Devonian period, often called the Age of Plants, saw an explosion in plant diversity and complexity. Plants began to develop true roots, anchoring themselves firmly into the soil and accessing water from deeper underground. Leaves began to evolve, increasing the surface area for photosynthesis and making energy production more efficient. With these innovations, plants could grow larger, denser, and more complex. Soon, the first true forests began to appear. Towering plants, some reaching heights of over 30 meters, dominated the landscape. Among them were ancient groups like lycophytes, horsetails, and early ferns. These were not trees in the modern sense, but they formed dense, swampy forests that covered vast regions of the planet. Their presence dramatically altered Earth's ecosystems. These early forests played a crucial role in shaping the climate. Through photosynthesis, they absorbed large amounts of carbon dioxide from the atmosphere and released oxygen. Over time, this led to a significant drop in global carbon dioxide levels, contributing to cooling climates. At the same time, the buildup of organic material in swampy environments led to the formation of vast coal deposits, many of which are still used as energy sources today. Reproduction also evolves during this time. Early plants relied on spores, which required water to reproduce. But eventually, a revolutionary development occurred: the seed. Seeds allowed plants to protect their embryos, store nutrients, and disperse across greater distances. This innovation freed plants from their dependence on water for reproduction, allowing them to colonize drier environments and expand their reach even further. By the late Devonian and into the Carboniferous period, plant life had transformed the Earth into a green world. Dense forests, rich ecosystems, and complex interactions between organisms had become the norm. The atmosphere now contained significantly higher levels of oxygen, supporting the evolution of large and active animals. In many ways, the foundation for modern life had been established. But this transformation was not without challenges. Changing climates, shifting continents, and evolving ecosystems led to periods of instability and extinction. Some of the earliest plant groups disappeared, replaced by more advanced forms. Yet each wave of extinction and evolution pushed life forward, creating new opportunities and reshaping the planet. The story of Earth's first plants is not just a tale of survival, but of transformation on a planetary scale. These ancient organisms took a lifeless landscape and turned it into a thriving, interconnected system. They changed the chemistry of the atmosphere, created the first soils, and built the foundation for every ecosystem that followed. Today, every breath of oxygen, every forest, and every field carries the legacy of those first plants. Their innovations continue to shape the world, reminding us that even the smallest forms of life can have the greatest impact.